In this lecture, we're going to discuss the two-way analysis of variance, also known as the two-way ANOVA. Now, I'm going to assume that you have some understanding of this particular methodology and how it's applied and when it's applied. And in our examples, we're going to be doing examples in SPSS. I'll show you how to apply the methodology in SPSS. I'll show you how to apply the post-hoc analysis, Tukey's HSD, on your data, and how to report both the outcome of the two-way ANOVA and the outcome of the Tukey's HSD in APA format. And as always, all code related to this video's exercises can be found in the video description below, along with an associated data file, which is structured in CSV format. So just a quick review of the two-way ANOVA. The two-way ANOVA is a statistical test used to examine the influence of two different independent variable factors on a dependent variable. It also assesses whether there is an interaction between those two factors. It is an extension of the one-way ANOVA, which involves just one factor. So here is our two-way ANOVA example. And again, the data for this example is within the video description below in CSV format. And we're just going to go through the word problem, and then I'll do it in SPSS, and we'll review the outputs together. So researchers want to test study habits within two schools as they pertain to student life satisfaction. The researchers also believe that the school that each group of students is attending may also have an impact on study habits. Students from each school are assigned study material, which in sum totals to 1 hour, 2 hour, and 3 hours on a daily basis. Measured is the satisfaction of each student group on a scale from 1 to 10 after a 1-month duration. So we have three separate hypotheses occurring. The first being that satisfaction levels do not differ depending on hours of daily study. So does daily study, the hours dedicated to such, impact student satisfaction? So that's our first hypothesis. Our second hypothesis is that satisfaction differs depending on school. So does which school the student is attending, is that impacting the student's satisfaction? And finally, we have the interaction effect. That would be the combination of school and study time in some varying magnitude is either impacting or not impacting the student satisfaction levels or the outcome. So let's take a look at our data in SPSS, and we'll go from there. So let me get our data here. So when you import this data from CSV, it's going to look like this. You'll have for study time observations of 1, 2, and 3, and for school observations of 1 and 2. You need to label these observations for study time. 1 is going to be 1 hour, 2 is going to be 2 hours, and 3 is going to be 3 hours. And for school, 1 is going to be school A, and 2 is going to be school B. Now, our dependent variable is the satisfaction rating, the student satisfaction rating. Our factors are study time and school. So these are our categorical variables. They are our factors when we're dealing with a two-way ANOVA, and those are study time and school. And our levels are found within our factors. So our levels for study time are 1 hour, 2 hour, and 3 hours of study time. And our levels for the factor school are school A and school B. So again, dependent variable, factor study time, factor school, 1 hour, 2 hour, 3 hour as the levels for factor study time, and school A and school B as the levels for factor school. So let's go ahead and run our analysis. We're going to go to Analyze. We then go to General Linear Model, and then we're going to select from General Linear Model. So Analyze General Linear Model Univariate. For dependent variable, we want to make sure satisfaction is placed there. And for our fixed factors, that is school and study time, as mentioned earlier. Make sure that for our post-hoc, that Tukey has been selected, and make sure both of our factors have been selected and moved to the right. Also, it's worth mentioning that if you wanted to change your significant level, you could change it here. In doing so, that would impact, obviously, your results and your findings, but we're not going to change that because our alpha value is 0.05, so it's unnecessary. So everything is set. So let's go ahead and click OK. Now, let's take a look at our findings. So this is the information which is populated as a result of our actions within the output window. Now, what we need to do also, because we want to run post hoc analysis, I'm going to give you a little spoiler here. There is a post hoc analysis, Tukey HSD. We are going to be utilizing it because there is significance as it relates to the two-way ANOVA. So we're going to also need to get the means. So we need to go to Analyze, Compare Means, Means, and we found significance as it relates to study time. So make sure study time is placed in layer 1 of 1 and satisfaction is placed in dependent list. Dependent list is always going to be your dependent variable. And as it relates to any findings that you have, as it relates to your factors, if there is significance, you will put those factors down here. Make sure for your options that you have mean, number of cases, and standard deviation on the right. Click Continue, click OK, and that gives you this output here, which you'll need for APA format when you're doing the post hoc findings for Tukey's HSD. So let's now return to the slides. We're done with SPSS. We have all of the necessary output, and we're ready to analyze the output and make our conclusions. So let's return to the slides. All right, so we had 3 hypotheses. So for hypothesis 1, there was a significant difference between the levels of study time as it pertains to satisfaction. Well, here is study time in our two-way ANOVA output. And as you can see, as it relates to study time and satisfaction, we see that our value is 0.037, which is less than 0.05. So we reject the null hypothesis, and there was a significant difference between the levels of study time as it pertains to satisfaction, because this here, study time, is less than 0.05. So we reject the first null hypothesis. Students of different schools did not significantly exhibit different satisfaction levels. Why is that? Well, let's take a look at school. So school for significance is 0.572. 0.572 is greater than our alpha value of 0.05, so we will fail to reject the null hypothesis. So students of different schools did not significantly exhibit different satisfaction levels. And finally, we look at our value here, school star study time, and that is 0.628 significance, which is greater than 0.05, so no interaction effect was present. So only study time and the hypothesis related to such is significant because it's 0.037, which is less than 0.05. So how do we state this in APA format? Well, in your methods section, you're going to say a two-way ANOVA was performed to analyze the effects of study time and school on student satisfaction. All right, so let's go to student satisfaction and study time first. So student satisfaction, study time, here's our degrees of freedom, 2 for the F, and then this error, 24, is the other value outside the F parentheses. We then place here the value of F, which is 3.809. So that is rounded to 3.81. So that's 3.81 here. And then the p-value is 0.037. That rounds to 0.04. So that's where there was the significance. Now for these others, there was not significance. This right here is the school attended. So here is the school. So 1 goes here, 24 goes here. Here is the value for F, 0.329, that rounds to 0.33, two significant figures. And our significance value is 0.572, so just 0.57. And you can see what's going on as far as the interaction effect is concerned as well. And we'll get into what an interaction effect means and how to interpret it momentarily. So because our findings were significant as it relates to study time, we're going to do a Tukey's HSD post-hoc analysis, which is one of the most common post-hoc analyses which can be utilized to do post-hoc analysis. And we did that in SPSS, and this was our outcome here. So as you can see, there is a significant differentiation as it relates to the Tukey's HSD methodology between students who studied for 2 hours and students who studied for 3 hours. So we can see that as it relates to the two-way ANOVA in our findings, that the main differentiation as it relates to study time was between students who studied for 2 hours as measured against students who study for 3 hours. And we need the mean for students who studied for 1 hour and the mean for students who studied for 3 hours. And we need the mean for students who studied for 1 hour versus 3 hours. So what do we have here? Did I mess this up? Post-hoc comparison using the Tukey's HSD test indicated that there was a significant satisfaction. There was a significant indicated that the student satisfaction for this actually should be 2 hours of study time. And then in here, we actually should be instead putting 7.20 and 2.62 was significantly different than 3 hours of study time, which is 3.70 and 2.00. And can you see where I made the mistake? If you can, I would give you extra credit. But the mistake is because it's 2 hours and 3 hours. 2 hours and 3 hours is where the difference is. So we don't really care about 1 hour. We would have to report for 2 hours and 3 hours. So post-hoc comparison, if this was done right, post-hoc comparison utilizing the Tukey's HSD test indicated that there was that student satisfaction for 2 hours of study time. Mean is 7.20, standard deviation 2.62, two significant figures, was significantly different than 3 hours of study time. Mean equals 3.70, standard deviation 2.00. So let's quickly talk about interpreting interaction, because this is very important, and it's really a concept which is unique to ANOVAs, which have multiple factors, or two-way ANOVAs. So if you come to an interaction, you have to stop and really think about what's going on. And here, our school and study time interaction is 0.628. So when would we stop and start interpreting interaction? Well, we would do that if this value here, this 0.628, was a value that was less than 0.05. So if this value for school and study time was, we'll say it was, I don't know, 0.01, well, that would mean that the interaction was significant, and we'd have to proceed with caution, and we'd have to proceed as such. So again, pretend that study time is still significant. It's still 0.037, and school is still not significant. It's still 0.572. But we'll say that school and study time is also significant. It's 0.01 or something like that. This is how we'd proceed. So if there is an interaction, we wouldn't be able to appropriately interpret the main effects, and we can only interpret the interaction, meaning that we wouldn't be able to say anything as it relates to study time. We would only be able to interpret the interaction effect. So this, school and study time, even though this is significant, we couldn't interpret either of these. We could only interpret study time. So what we would report in that case then would be that there was a statistically significant interaction effect of the school variable on the study time variable. Again, we're pretending that this indeed was the case. We report the F values for school study time and the error. We'd report whatever the significance was, and we'd also have to report the F value. So we report this value as well, 0.475, rounded to 0.48. So we would only report that. We would not report anything else. Now, there's a lot of confusion as to how to interpret interaction, or like what interaction actually means, other than, what you just wrote in APA, and other than you need to stop and think about it and report your results and such. And think of it like this. This gentleman on the left, he likes peanuts and he likes chocolate, but he doesn't like them together in peanut juice. And this is the example I often use when describing this concept to someone who inquires about it. An interaction effect essentially occurs when one independent variable, in this case it's peanuts, is impacting an other independent variable, in this case it's chocolate, and as a result of such, that interaction is impacting the dependent variable. Dependent variable in this case is this gentleman's satisfaction with peanut juice. So one independent variable is impacting another independent variable, and the result of such is impacting the dependent variable. So perhaps the amount of peanuts and the amount of chocolate, or some interaction between the measurements, is impacting one another, which is then impacting the outcome. So you can think on that, just like this gentleman is here. Sorry about making that error in that particular slide. I'll post something in the video description below, which hopefully will make it clear. But that is all. So if you enjoyed this video and it helped you out, please consider liking and subscribing. If you have any questions, maybe leave a comment so we can help one another out. We're trying to get this message out to as many users as possible. So best of luck in your research, and thank you for stopping by. Until next time, take care.